Alright, in this video what we're going to look at is the properties of logarithms, and just do a couple of examples with these two examples with these three properties. And one of the things that's expected that you can basically be able to take a log that's condensed and expand it out, or vice versa, take something that's already expanded and then condense it into a single log. So there's a little bit of practice. These usually aren't. And the first one we're going to look at is we'll do an expansion here. So let's expand log base 2 of 4 over the square root of x plus 8. What we're gonna do here is basically take this already condensed log and we're gonna expand it out. And the thing that you'll notice in this particular case, you got this here. So this will lead us to is we're going to use the quotient rule here, and basically this divisor can be split up with subtraction. For a proof of these, you can check that out somewhere else. Today I just wanted to use these properties. So this divisor is pretty key, and what I'll notice is this 4 is in the numerator. Anything in the numerator is going to be a negative logarithm. So what we'll do here, we have log base 2, and this 4 will be a positive, but the denominator is going to be a subtraction. So we take away this log of base 2 of the square root of x plus 8. And there's actually a couple more steps we can do. In this particular case, log base 2 of 4, this is just a number, nice number actually. We can just write it down as 2 because 2 squared is 4. So this is just 2. But the other thing that happens here, we can use the power rule as well, as this square root is the same thing as the exponent of 1/2, and then one more step here, the power that whatever is raised to some exponent out as a multiplier out in front. And in this case, 2 minus 1/2 log base 2 of x plus 8. And that's all we can do with this one. We can't break this apart or anyway. Sometimes it's really tempting to break this apart, but this is not a product in here. It's an addition, and order operator would require us to keep it this way. So we can't do anything with this. This is simplified, and that's the full expanded logarithm of log base 2 of 4 over the square root of x plus 8. Another example, we'll be doing this in we've got an already expanded log and we want to condense something about like this. 2 log base b of x plus 8 log base b of y minus 1/2 log base b of z. And in this case, what we're going to do is bring it back into one logarithm, and we can do this. We might have noticed before they've been like, so these, first thing you kind of notice are that the bases are the same for all of these things. And what we'll work on doing in order to, we'll do is this multiple is going to end up being an exponent for the x. This 8 is going to be an exponent for the y, and this 1/2 is going to be an exponent for the z. And then we'll be able to condense these from the product rule and the quotient rule using the positive and the minuses here. So this first one, log base b of x squared plus log base b of y to the 8th minus log base b of z to the 1/2. And now I'm ready to use these addition and subtraction signs to apply the product rule and the quotient rule. So the positive ones, this one's positive as well, so these positive ones are going to end up being in the numerator. The minus one, the subtraction, is going to end up being in the denominator. So this can finally reduce down to 1 log base of x squared times y to the 8th over z to the 1/2. And this is now fully condensed. One other option, because this 1/2 could be written as a square root, you could take that one step further and write it this way. It was perfectly fine as it was too, but the square root of z is maybe looks a little nicer. So condensing logs and expanding logs use the same properties. There's a couple examples. Hopefully that helps explain and how you can use those properties of logarithms.